So in this video, we're going to take a look at graphing from standard form. This is similar to graphing from vertex form in the fact that you have to find the vertex. What's different is that the vertex isn't just given to you. So if you remember from last year, we find the axis of symmetry, which gives us the x-coordinate of the vertex. Remember, a is the coefficient of your x squared term, b is the coefficient of your x term, and c is your constant. So to find the x-coordinate of your vertex, or the equation for the axis of symmetry, you do the opposite of b all over 2a. And in this case, a, the coefficient of our x squared term, is 1. So negative 6 divided by 2 gives us an x-coordinate for our vertex of negative 3. To find the y-coordinate for our vertex, we substitute the 3, the negative 3, back into the function and solve for y. Alright, this is taking me forever. I have a tablet that is supposed to allow me to write on it, and it was working for all of those videos I had to delete. And then once I figured out how to get the recording, the tablet decided to stop working on me. So we have to use our mouse. Alright, I finally have it substituted in, and when you evaluate all of this, you get, let's see, negative 4. So the coordinate for our vertex is negative 3, negative 4. Alright, you can at this point create a t-chart if you would like to, and evaluate this the same way that you do vertex form. Another option is looking at step 4 over here, finding the y-intercept, which is substituting 0 for x, and then when you graph, you can flip that point across the axis of symmetry. So I'm going to label this with V for vertex because it will take me forever to actually write out the word vertex. Substituting 0 for x, the a term and the b term disappear, leaving us with just the constant of 5. And I'm going to put y for y-intercept. Alright, at this point you want to make sure that you have all of this down, because when I scroll I have to take off the draw function, and this is all going to disappear. I'm really not sure why, and it's kind of frustrating, but that's what's going to happen. So make sure you've got all of this information. I'm going to scroll down and we're going to graph. Alright, so as a reminder, our vertex was negative 3, negative 4. And the y-intercept was 0, 5. Again, you can make a t-chart around the vertex if you like to. I'm going to show you how to use the axis of symmetry instead. So graphing that vertex at negative 3, negative 4, and the y-intercept at 0, 5, what you do is you kind of create this imaginary line through the vertex, and then you flip the y-intercept across the axis of symmetry. So now we've got our vertex, and we've got these 2 points that we can try and hit with a nice, smooth, rounded U-shaped curve. Mine's looking a little bit more like a V, so try and make yours a little bit more rounded. Alright, going on to the next slide. Again, if you feel comfortable with vertex form, standard form, feel free to skip to the next video. If you would like one more example, I'll do that for you. So first step, finding that axis of symmetry. We get opposite of B, so in this case our B is negative 4, so the opposite of that is positive 4, over 2 times negative 2. So we get 4 divided by negative 4, or negative 1. Sorry, the other half, my equal sign disappeared. So we substitute that value into our function to solve for y. And instead of writing it all out, I will trust that you know how to substitute, replace your x with negative 1, and for my y value I got a 9. So our vertex is negative 1, positive 9. To find the y-intercept, substitute 0 for x. When you do that, you get just the 7 left, your constant. All right, I'm going to scroll down to the graph again, so make sure you have all of this information. All right, the coordinate for our vertex was -1, +9. Our y-intercept was 0, 7. Flipping that across the axis of symmetry, we get another point over here. And let's see if I can't make this parabola a little bit more well-rounded. Yeah. No, not really. All right, and there is sort of our graph. You also want to make sure that your graph matches your equation. So if your graph is opening down like ours is, I'm going to scroll back up so make sure you have this graph. The A value should be negative. If your A value is positive, your graph should be opening up or down, which is step 1 right here, and I just skipped right past it.